Good afternoon everyone. In this video we are going to discuss about module 5 in the mechanical measurement and metrology subject. So first we are going to discuss in this topic measurement of force, torque, pressure. First we are going to discuss about the force measurement. Before going into the force measurement, so in this topic, in this module we are going to discuss about measurement of force, measurement of torque, measurement of pressure, measurement of temperature, as well as measurement of strain. So these are all the things we are going to discuss over in this particular module. So in this particular video we are going to discuss about the force measurement. So in this force measurement we are going to discuss about introduction, force, direct method and analytical method. Okay, so here first we are going to discuss about the introduction of the force. So already we people know that the force is the reaction between the two bodies. Okay, so it may be the reaction may be the tensile force or compressive force. Either we can say that it is a pull or a push force, it will be acted over here. So the force represented mathematically a vector and as a point of the application, and also the measurement of force involves the determination of its magnitude as well as its direction. Okay, then the measurement of force may be done by any two methods. Okay, so what are the two methods? Means one is the direct method and another one is the indirect method. So in the direct method, it involves the direct comparison with the known gravitational force to the standard mass standard mass. So the example is the physical balance. Already people know that we will explain in the physical balance. So one side they are going to keep the known weight, other side they are going to keep the whichever things they are going to measure. So for both the things it will be equal. So then the measuring quantity it will be equal to the whatever weight we have put over the, it will be equal to that, like this. So this is the direct method and easiest method. Okay, there is no complexity over here. Then comes into the next one, indirect method. So indirect method, it involves the measurement of effect of force on a body. So this is the indirect method. So example for in this one, measurement of acceleration of your body is known mass which is subjected to a force. Then next one, measurement of resultant effect when the force applied on a elastic member. So these are all the examples for the indirect method. Okay, so first we are going to discuss about the direct method. Okay, in the direct method, a body of the mass m and the gravitational force field experience with the force f, which is given by f is equal to ma. That means mass into acceleration equal to w. Okay, so here w we can say is the weight of the body, as well as the a is acceleration due to gravity, m is the mass. Okay, so in this one, so in this direct method, any unknown force may be compared with the gravitational force ma on a standard mass m. The values m and a should be known accurately in order to know the magnitude of the gravitational force. Okay, so here mass is the fundamental quantity of standard is called kilogram. So normally about these things we are going to discuss about like material standards. So in the length material, okay, like rapid prototype meter, it will be kept in the France. No? Same like in this kilogram also it's kept on the France. Okay, so the other mass can be compared to with the standard with the appreciation of few parts in the 10 power 9. So on the other hand, a is derived but still makes convenient standard. Its value to be measured accuracy of 1 part in 10 power 6. So therefore unknown force and the unknown force can be compared with the gravitational force with an accuracy of about this order of magnitude. This is about the direct method. So direct method, directly you are going to compare the values. Okay, so one side we are going to keep the weight, and another side we are going to keep the whichever things we are going to measure. So the weight, it have mass, so the acceleration due to gravity. So it will be acceleration due to gravity. Okay, so m into a, so usually mass into gravitational force 9.81 is equal to weight. Okay, so this is about the direct method. The next we are going to see about the analytical uh, method. So the analytical method is shown over here. So it will be look like the weighing machines. So there this pointer, it will be connected to the scale over here. Then the weights, these things it will be acted over here. That we will see about the constructions. First, so the direct comparison of unknown force with a gravitational force can be described with the help of the this analytical balance method. So the direction of force is parallel to the gravitational force over here, and hence only the magnitude and magnitude needs to be determined over here. So the details of the analytical balance, they are provided in the drawing. So in this drawing, the balance arm is rotate about the point O. So it will be rotate about the point O. So here there are two forces it will be acting. One is the W1 and another one will be the W2, are applied on the ends of the arm over here. So here W1 is the unknown force and W2 is the known force. Okay, then here the G, it will be act as the center of gravity. So exactly in the balance arm, so the WG, it will be act on the center of gravity. So here, okay, so the next thing, the balance is unbalanced position when the force W1 and W2 are unequal. Okay, so if both the things W1 and W2 it will be equal, then this one it will become 0. The angle of theta it will become 0. Suppose the W1 and W2 it will varies, angle also it will be varies. Okay, so the balance position, then the weight of the balance arm and the pointer do not influence the measurement. Okay, so the sensitivity of the balance depends as the angular deflection per unit of unbalance between the two weights W1 and W2. So S is equal to theta by W1 minus W2. So S is equal to theta by del W. Okay, so here once the see the construction. So according to the point O, the point O, it's going to be rotated. So here it will be going to fix over here. So about the point O, it will be going to rotate. So from the point O to the weight W and W2, the distance will be the dB. The vertical distance, you can say it is a dB, and the distance between the point O to W1 and point O to W2, the horizontal distance will fix it as a WL. Okay, so this after fixing this, the angle between from the pointer to the WB, it is going to theta. Suppose W1 and W2 are equal, that theta will become 0. Okay, so now we are going to take the moment about the point O. So it will become W1L cos theta minus W1 dB sin theta equal to W2 L cos theta plus W2 dB sin theta plus WB dg sin theta. So while simplifying this formula, we are going to get like a uh, the value will be going to get 1 L by W1 plus W2 into dB plus dG WB. So those value are going to substitute in this particular equation. Then we are going to get L by 2 WB plus WB into dG. So here finally after some dB will become 0. Okay, so it is a small reflection, so the dB is equal to 0, then that equation S is equal to L by WB dG. So that the sensitivity we are going to measure with help of this formula L by WB into dG. Okay, so the sensitivity depends upon the construction parameter of the balance arm and is independent of the weight compared. So the sensitivity can be improved by decreasing the both WB and DG value and increasing L. Okay, this is about the analytical method. Okay.